Good evening and welcome to tonight's talk on Merseyrail's fleet replacement. I'd like to begin by thanking you all for joining us tonight, and I hope you both enjoy and learn something new from tonight's talk. This evening you will hear about the fleet of new trains with a host of customer-orientated features that are destined for the Merseyrail network. A quick note on tonight's event, which regrettably we had to postpone our scheduled presentation on new deep tube trains for London to await the completion of the final design stage for the new train, and also to allow joint publicity events for TfL and Siemens to take place. We are hoping to bring you this presentation later in our programme, or possibly to open the 2021 events season with that one. So by ways of introduction, my name is Toby Johnson, and I am the chair of the South East Centre of the IMechE's Railway Division, and I'll be chairing tonight's meeting. I'm joined on the panel by our speaker David Powell, who is Programme Director for Merseyrail, and I'm also joined by South East Centre Secretary Kevin Moore, who will be chairing the questions and answers session. As always, questions can be asked throughout the presentation using the Ask a Question function on your screen. Please do use this function to ask David questions about his presentation. David will be answering questions at the end of his talk, but submit your questions throughout the presentation as you think of them. So with the introductions done, I'd just like to tell you about the Future of Rail competition. The Future of Rail presentation competition for young engineers is still accepting entries until the 25th of January. This is a fantastic opportunity for you to demonstrate your competency in communication, showcase your work to the industry, and be in with a chance of winning one of 3 cash prizes. The South East Heat is being held on the 15th of February. And the winner will be announced on the night and go on to the national final. Presentations are limited to 10 minutes long with a 5-minute Q&A session, so it is a good challenge. To enter, if you could submit a 200-word abstract to our organiser, Chen. The email address is on your screen, and hopefully Emma's going to post that email address into your chat log as well. Yes, so please email Chen if you were interested in presenting in the competition. So next we have our upcoming events. As I mentioned, the Future of Rail presentation competition is on the 15th of February. I'd encourage everyone to attend that, as it's always a range of excellent presentations on a wide range of rail topics. On the 15th of March, Malcolm Miles, Head of Plant at Network Rail, will be giving a talk on the latest on-track plant for infrastructure maintenance. Another interesting talk for your diaries. And on the 19th of April, we're looking forward to hearing about the challenges of introducing the Crossrail fleet on the Elizabeth line. And as I said previously, we are waiting to confirm when we can have our new deep tube trains for London talk. So please keep an eye on our Near You website to keep up to date. So without further ado, I'd like to introduce tonight's speaker. Tonight we have a speaker who's highly qualified to give tonight's talk. I'm sure that he will talk openly and candidly about the Merseyrail fleet replacement and provide you with an insight into the world of Merseyrail. So David Powell has over 30 years experience of public transport industry. He is leading the project to replace the Merseyrail fleet of rolling stock and an associated programme of infrastructure improvements. Initially a rolling stock designer, David has been a project director for the last 20 years, working on a range of railway, metro and tram projects worldwide for both public and private sector. Please give David your full attention, and I hope that you enjoy tonight's talk. David, I would like to invite you to give your talk.
Okay, thank you very much, Toby, and a pleasure to be back in the capital. And I'd like to come along to some of your forthcoming presentations. I'd particularly like to see how the Crossrail fleet are getting on. That'd be interesting. And I remember the Deep Tube because the procurement of that was launched 2 days before we launched our procurement. So it's quite interesting. I'd love to see congratulations to my friends at Siemens for securing that. And again, I studied in London. I've lived in London for 10 years, so I know your city reasonably well. But I've subsequently moved back up to closer to where my heartlands are, back up in the north of England. And I've been working in Liverpool now for the thick end of the last decade, working on the replacement of the Merseyrail fleet. So a little bit about an organisational background. Click into the first slide. So I'm guessing, compared to my normal audiences, I guess a lot of you won't be quite as familiar with our network as people who up in this part of the world. The Merseyrail network is an intense network. It's in many ways it's more like a metro network than it is a mainline network, but it is mainline. It's the Network Rail own our infrastructure, and with all the mainline standards still apply, but the operation feels very much like a metro service. And as Toby mentioned, I've got quite a broad cross section of working on mainline metro railways and most notably tramways in this country, where 3 of the tram fleets are ones I've introduced over my career. And I've been trying to blend the best of all of those types of railway onto our rather unique network. So there's a rather clean looking version of one of our trains down the bottom. Actually, they're all looking rather good. COVID gave us a damn good chance to clean them all properly. But our rolling stock, some of you will be very familiar with these fleets or their cousins, many of which are operated down south. They're the 507, 508s. It's the DC version of the British Rail 1970s rolling stock. And our network, we're technically different from the other railways in our parts of the world. We're virtually surrounded by diesel lines with a little bit of overhead that spills in from the West Coast mainline, but we're DC, so we're the north of Watford. We're the only other mainline bit of DC railway in the UK. Our network was transformed. It was a variety of disparate railways created by different countries back in its Victorian past. And back in the 1970s, there was a transformational. I'm very conscious there's a question saying, please sort out the presentation of people talking together. Is that still the case? Oh, crikey. Is the presentation visible to people? Can somebody just type and say visible or not visible? Because I can see a question that says, please sort out the presentation. Okay, I'll carry on. I'm hoping it is visible for everybody. So we were transformed in the 70s by the creation of the loop and the link, which is the underground section of our railway. We had tunnels coming underneath the River Mersey, which runs through the city centre, but a loop was created so that all the lines from the Wirral run round under the city centre, and the link was a north-south connection, again running through the city centre, and there was good interchange design. Our fleet, there are bits of rolling stock which are older than ours. Good, I can see lots of people saying visible. Thank you very much, I appreciate that. We are, if you look at all the train operating companies in the country, this is a little bit out of date, this graphic, but those are ages of fleet, and we're over on the right hand side. Our fleet now is coming up to 42 years old, the oldest parts of it. So we do have the oldest fleet in the UK at the moment. Still doing rather well, and surprisingly, we've just reached our highest ever level of reliability. It's amazing what you can do with a railway when most of the passengers disappear. Anyway, there we go. The management of the railway has been devolved. So I actually work for Merseytravel, not Merseyrail, but it's great that an awful lot of people don't see the distinction between us, and it mirrors what the arrangement that you have in London. With the London Overground, so that was I think that when TfL were coming up with that arrangement, what we'd done a few years earlier was possibly one of the models that was being looked at. So I'm Merseytravel, we're the passenger transport executive. If we were in London, our peers would be TfL, but obviously TfL is a much larger operation than we are. And our operator is Merseyrail, who are running a 25-year concession that kicked in under our direct management in 2002. So the Department for Transport are not directly involved in the day-to-day management of the contracts that we run. The railway has been characterised by incremental improvement since that time, and we've gone from having the rather unfortunate title of Merseyrail, which is what I remember as a kid the railway being known as, which I think was a little bit unkind, but moving towards being passenger Operator of the Year in 2018, and routinely we take some pride in the fact that in terms of passenger satisfaction and punctuality of the various mainline operators around the country, we're normally somewhere near the top of the table. Okay, so what's the point of introducing new fleets? If it's all so wonderful, why do we need new fleets? Well, the age of the fleet is the underlying reason. We're not going to be able to keep the trains going forever. What are we looking to achieve? Improvements in safety. One of the features of our railway, unfortunately, we had a very serious, fatal accident, more than serious. That was back in 2011, and a very clear set of recommendations from the RAIB, which the RR are working with us on to make sure that we fully deliver those. So there's a platform train interface improvement, and platform train interface is a real theme of what we're up to. We're looking to reduce journey times, and that's by introducing a more powerful train and boosting the power supply. Increasing demand. Now, this might seem a bit ironic in the current climate because our patronage has fallen off a COVID-shaped cliff, which I'm sure is the same for just about every railway in the country. I haven't seen anybody who hasn't suffered exactly the same thing. But we were living with 2 to 2.5% rising demand. Trains getting increasingly full. And we needed additional capacity on the railway to meet that long-term rise in demand. So part of the rationale was we need to be able to carry more passengers. Hopefully that world will return as we emerge from the COVID pandemic. Improving the passenger facilities. The old trains were basic, I think it's fair to say, reasonably comfortable, but quite basic. And we want to be able to expand our railway. So at the moment we're defined by the third rail. That's where our trains go. They run around on the third rail network. We want our trains to be able to operate beyond the third rail without forcing passengers to interchange, which is what happens at the moment. Accessibility features very large in our thinking, and rather than talk about that here, I'll show you a bit of that later. But our ambition is to become the most accessible heavy rail network in the UK. Improving reliability. Well, if you're going to buy a new fleet of trains, buy one that's reliable, and I know that's a challenge many people in the industry are facing with new fleet introduction. That's one that lies largely ahead of us because we're not yet in passenger service. Reduction of operation and maintenance costs. That includes taking the electricity consumption down there by reducing the carbon footprint. We have a self-financing, sustainable business model, and we see the railway as very much a part of the economic engine of our city region. We see that the introduction, the investment of nearly £500 million into our railway is an economic boost that will add £70 million to economic activity across the region, which is not a bad investment for a set of assets that should last 35 to 40 years. Okay, this slide's really boring, so I won't talk about it too much. It's sort of interesting. The key message is that this goes with devolution. The model that we set up is not the same as most of the other business models that you see on the mainline railway since privatisation. So we've got devolved management of the operation. There's a series of savings that we see: energy, maintenance costs, operational costs, and then hopefully over time additional revenue flowing from providing a better service to passengers. And we see those flowing back to us as the awarding authority. And part of that was we took a long, hard view. We've had a very successful business relationship with Angel Trains for many years now, who own the current fleet. But we looked at the alternative of if we stepped into the Roscoe shoes ourselves and owned the rolling stock ourselves, what difference would that make? And the answer is we think it's very beneficial for us. So we took that choice. We're going to own this fleet of trains. We led the procurement model, therefore, was led by us rather than effectively us delegating it to a third party. Financing, very simple. It's public sector-based financing, so that's using our own reserves that we've accumulated over time. Public Works Loan Board, which is the Treasury, which is available for local government organisations, and the European Investment Bank. I think I was one of the very last UK projects to manage to scramble over the drawbridge of the European Investment Bank as it was going up in the aftermath of the Brexit vote. But we managed to borrow £190 million from the EIB. We explored contracting out maintenance through our procurement and decided that was the right thing to do, and that's how it happened, and it's been successful, getting the balance of risk right between the parties. And the result of this is we're going to be the UK public sector's only owner of mainline rolling stock, which we think is a very exciting opportunity. Okay, a little bit about the trains themselves. We ran a competitive process. We had 5 bidders pre-qualified. Following a strong competitive process, Stadler was selected as our rolling stock provider. And a feature, something that we'd done right back at the beginning, this is a bespoke fleet of trains. We wrote a specification for our fleet of trains. This wasn't a spec that just says, please can we have a version of someone else's trains painted up in our livery. This train has been designed from scratch for us. And one of the parts of the ethos we wanted to do was to get passengers' involvement into the design of the rolling stock. We did that in 2 stages. We worked with Transport Focus, who have a very good research division. I'd thoroughly recommend it. I don't know if they're in the audience, but there's a plug. But seriously, we got some really great insight before we procured as to what our passengers might want. And then once we'd awarded the contract and we were going through the design process again, we finessed and we refined lots of design features. And I think the input of passengers really improved the design of the train that we're coming up with. I think they helped us make some really difficult choices, many of which were not the ones I think that I would have made had it been left out to me, but I think they're better. One of the most obvious is down at the bottom of the slide. You can see the livery of the train. That looked completely different when we awarded the contract, but we showed the passengers alternatives. It's a version of the Merseyrail colour scheme, which is yellow, silver and black, and I think we've got a really iconic livery design. The interior of the train changed dramatically as a consequence of passengers telling us what they want. Okay, so the rolling stock, as I said, was bespoke. Design process was completed in what I think is about as quickly as you could possibly go. It was a joint effort between Stadler's factory in Altenrhein, which is over in the east of Switzerland, just close to the Austrian border, and Valencia, down in Spain, which is also where the bogies were built. So I characterise this as a metro-style multiple unit designed to mainline standards. Manufacturing spread around, but the body shells, it's all welded aluminium, which is Stadler's specialism. They come from a specialist body plant in Hungary, extremely good quality. The bogies came from Spain. Again, it's a nice lightweight bogie that just fits the type of operation that we're looking for. 2 assembly plants, the one that I mentioned in the east of Switzerland, and then we've got one in a city called Siglice, which is over halfway between Warsaw and the border with Belarus. And yes, it's blooming cold, but I'm not allowed to go there anyway, so I won't experience the Polish winter again, at least not this year, I don't think. Our dynamic testing started in Germany in late 2019. We used the Wildenrath test track, which is owned and operated by Siemens, which I'm sure many of you have done rolling stock introductions. A lot of people end up at Wildenrath, well, so did we. First unit came to the UK in January 2020, and then so did COVID, which has really been a real challenge for us. As you can see, the team that we're working with is very international. And the big problem, there was an impact on manufacturing. That hasn't been the real problem. The problem has been getting testing and commissioning engineers to be able to move between the various locations that they need to be. So the testing program was intense. It always was. It's a brand new design of train. And here we are a year later, and we are still, I'm afraid, approaching completion. We should have been done quite a lot earlier, according to the original plans. But if you can't get the people into the country, you can't test the train, I'm afraid. So COVID, I'm afraid, has been a real shock to us and continues to be. Okay, a little bit of a peep inside. This is actually using the computer. The 3 of these are computer-generated images. I confess I was a complete skeptic about putting the headset on, because I'd seen really clunky stuff from years before, when Stadler and their designers did this with us, and we had the virtual experience. my scepticism disappeared pretty quickly, because we were really able to use these computer-generated tools to help finesse design features. Really powerful, that we used at the early stages. Later on, we used wooden mock-ups, and the image at the bottom right is that's a full-scale wooden mock-up of our train next to a full-scale wooden platform that we had on show in the middle of Liverpool. And again, we used this with our passengers to finesse the design, and I think it was extremely successful. But the train is different in its look and feel. Light, bright, open and airy. Same seating capacity as the original train, but with better seat spacing, better leg room. We're very conscious of the feedback that some other railways have received about uncomfortable seating. We think we won't fall into that area. And an area where, again, working with our passengers, we knew the trains were weak. The standing areas were not great. They were quite constrained. There wasn't much to hang on to other than the other passengers. So we've got a much more usable aisle and vestibule areas, which are considerably bigger than the original ones. Proper standbacks at the doors. We think circulation on these vehicles is going to be a massive improvement over what we've currently got. Okay, and here's the first unit. I just like this picture because this was the sun was just going down and it seemed to have a slightly amber glow. This was about 15, 16 months ago, just as the first train was on its way off to Wildenrath. Okay, here's the interior. So this isn't CGI. This is the reality. Again, hopefully you'll see that the computer-generated work is a really good representation of what we've actually ended up with. Characteristics of the train, I would say that the aisle is wide. I wanted two passengers to be able to get past each other. We decided we wanted to stick with our 2+2 seating rather than going back to 3+2, which our old fleet was originally. Lots and lots of passenger information screens, and we have big ambitions for what we're going to use our screens for. And the windows on this train are absolutely huge. That's very deliberate, but the air conditioning works. So the solar, again, doesn't appear to overpower the air conditioning. Okay, this is just a nice picture. This is our first unit. It's on its way to Wildenrath. This was going through the North Swiss countryside. And recent arrival, it's not actually that recent. This actually, this is a slide I probably should have edited. This was 007, and I'm sure you can guess what all the Scouts wags named this train. James Bond, there it is. This was actually our first train to come from Poland. So number 5 and number 7 arrived from the Polish factory. This was back in the tail end of the autumn last year. And we've got into some very strange arrangements of doing lots of activities in the wrong place. So I did what's meant to be the pre-delivery factory-based acceptance of the train at our depot because we couldn't get to the factory. So we're doing all sorts of things by very, very strange means. Around the same time as this, I'm sure many of you will be familiar with the challenges that testing EMC can present on a brand new design of train. You've got to take it very carefully. We all know that if it's not done correctly, you can end up with all sorts of problems. And we managed to do this without the traction supplier being able to attend site in Liverpool. So we did all of the local testing. So the traction supplier is ABB, who produced a great bit of kit. It's got a low EMC footprint. The train, that's what all the design said. And we were able to test it and demonstrate that there was a lack of interference both with the infrastructure and back the other way as well. But doing that by having the traction supplier sitting remotely in Switzerland while we had people who weren't traction engineers actually doing the testing was really quite something. I don't know if any fleet has ever done that before, not having the traction provider in place, but we managed it, and it went through the very thorough process that you would expect Network Rail to put it through, and we secured all the agreement to run around the network. It's been beetling around very happily for several months now. Okay, another view of the interior. It's for our railway. This is commonplace down in London. It's new for our area. Just an open saloon, so we're one connected tube, and they won't have these carpets on there. They're just there to protect the floor. But the saloon, light, bright, open, and airy. We think we've got it right, and it actually feels better when you take the black matting off the floor. But it's a good saloon, easy to circulate round. All of the seats tested with the passengers for comfort. All of the seats 450 millimetres wide. So we've given everybody a priority width seat, which we're pleased with. Better leg room than the existing trains, which again hopefully will serve as well. You don't have to play Tetris with your knees when you're sitting in these facing seats. Okay, this is something we're working hard on at the moment. This is a space in the underframe. So I mentioned that our railway is DC, and these trains have been delivered as DC only trains. They've got Shuge. This space was envisaged. It's got two purposes. So this is most of the length of one of the end cars. So we've got probably the thick end of 10 metres length of underframe here, with basically no equipment in it. That's one of the bogies at the end of the train that you can see down at the end beyond all the piping. And we had two things in mind, one of which was we could make this train dual voltage. So this would be a space where you could put a transformer, rectifier and an extra traction converter and make this train run on 25 kV or even 750 volt overhead if we wanted to. Interesting. Or we could put batteries in there. So I'm very well aware, have been for many years, that this technology is coming into the industry. We've had in mind that our network, a pocket of DC electrification, and on many of our lines, you come to the end of the route, and passengers walk down the platform and hop onto a northern diesel train. Well, why the hell do we want them to do that? Well, why don't we carry on through? So there are routes like the moment if you go from Liverpool to a place called Ormskirk, carry on another 15 miles and you've reached the middle of Preston, for example, which obviously there's 250,000 people live in Preston. At the moment, not many people who go from Preston to Liverpool come down that route because it's not the most convenient, and you've got an hourly service, and you've got what could be a bit of a faffy change to do in the middle. We're thinking routes like that, potentially we could expand our network and serve a much wider region with Class 777 units powered by batteries. So the equipment for a trial is being fitted as we speak. They'll be with us in April. And over the course of the late spring, early summer, we'll be undertaking trials to prove the key characteristics of a business case, which I think is really, really exciting. It makes a lot of financial sense. There's a lot of saving on infrastructure if you can provide your motive power from on board the train rather than having to put overhead wires up or try to extend your third rail. And we think we can get a good range. Now, I'm not going to make some of the claims that I've seen in the press. We're a little bit more cautious than that. But getting to somewhere like Preston, if you've got 5 tons of battery on board your train, you can certainly do that. We just have to prove it to ourselves and to all the other people watching us. So that's a really exciting time ahead for us, and we're hoping that we can provide the quality of Merseyrail service onto some of the lines which surround us, which are not as well served, and to give better connections directly into the city centre. So exciting times ahead for us, and please watch. And if anybody, hopefully, the Rail Live event will be able to take place this summer. I really hope so, because we're intending to take our battery-powered version of the train down to Warwickshire. And any of you want to come along and probably bump into me and have a look and kick the tires on it, it'd be a delight to meet you. So good luck to everyone else who's pushing battery trains. We've almost all got the same battery, by the way. I've worked that out. Okay. So it's not all about trains, albeit trains are the centrepiece. So £500 million programme, roughly slightly under £300 million of that goes into the rolling stock itself, which leaves the thick end of 200 and a bit thousand pounds to spend on infrastructure. And our railway has needed quite a bit of investment for a long time. So this was the right project to build this together. So our main maintenance depot at the moment is our Birkenhead North, which is over on the Wirral. We've had a larger depot, but basically a stabling depot with a wheel lathe, strange configuration, at a place called Kirkdale. This is a couple of miles north of the city centre of Liverpool. We've completely modernised this depot and turned it into our new maintenance hub. The facility you can see there, that's now full of 777 units. Construction's complete. We've got a driving cab simulator, which I'm sure many of you I've had these before. We've never had one on our railway, so we're really pleased with that. And it's been really configured well to work with the Class 777 units. And I'm delighted to say that it's also become Stadler chose to put their UK headquarters into our depot, which is great. So there's about 15, 20 people who are actually a headquarters function, as well as all the people who have now been forced to wear blue uniforms. And the Liverpool fans amongst the maintenance workforce are absolutely delighted with that because it looks very Everton. Okay, this is our simulator over on the left. And this was one of our final commissioning tests. Can we get an air conditioning unit from the store on and off the roof of the train? Well, the answer is just about yes, we can. It was a bit tight with the crane, but we got it there. Okay, I've talked about accessibility. We had a fatal accident. Gap between train and platform, like many other railways, is relatively, it's very variable across our network, or it was very variable. There was some clear recommendations from our AIB. Can you, when you replace the fleet, can you try and do something about the PTI? And then when we did our passenger research, the thing that almost sort of cemented the deal for me was that the passenger train interface and the step up and down between the train and the platform came across as the #1 concern for passengers. It was absolutely crystal clear. So all of the planets seemed to be aligned at that point. And I was thinking, how do we deliver the sort of thing that I've delivered on various tramways around the country, where tramways do platform train interfaces very well. They also generally, or at least the new build tramways, have the benefit of building their own infrastructure and usually making the platform straight, which makes it a little bit easier. But we were thinking, what can we do? Can we bring that type of approach onto the mainline railway? And the answer is yes, you can. So we've taken a different approach to how many people have looked at this. We see it as primarily, it started off as a safety benefit because there was a very clear recommendation. But obviously, accessibility goes hand in hand with providing a good platform train interface and also managing your dwell time, giving yourself an operational benefit. If we can get passengers on or off the train more quickly, then we think that potentially has the ability to help us manage dwell time more successfully. So the view that we took is we encouraged our bidders to explore different ways in which they could help us manage the PTI. And Stadler came up with a train. I told you this was bespoke. It's got a lower floor than your normal British multiple unit. Typical British multiple unit floor height 1100 to 1150. This has got a floor height of 960 at every single one of the passenger doorways. It's slightly higher over the bogies, an extra 100 millimetres over the bogies, but those aren't where the doors are. And then they have a sliding step, which is technology well proven in parts of the country such as Switzerland. The latest generation of this step slides out and it ultrasonically is looking for the platform, and it will stop 35 millimetres horizontally from the platform once it detects it. Put that together, we were forming a view that we needed to modify the infrastructure because we measured all our heights and offsets of platforms, and like probably most other railways across the country, they were basically all over the place. We had high, tight, wide, low, every combination, some platforms falling into at least two of those categories. So we took a view, right, we're going to adopt Network Rail's standard height and offset of 915 millimetres above rail, 730 millimetre offset on a straight platform, and we're going to rebuild the infrastructure so that every platform matches that. Will it work with the train? Well, the answer I can tell you is yes, it does. So we get a consistent platform train interface at every single doorway. So it's not just for wheelchair users, it's not just for people with buggies, it's for absolutely everybody. And we think it's going to be a great boon, and hopefully something that will have a wider application than just the Merseyrail network. Some of you who might have travelled on the Anglia network will have seen the I've lost my slides, they've gone. That's strange. Oh, okay, I'll talk without being able to read my slides. Emma, if you could help me, I'd be very grateful. I'm afraid all I can see is webinar. Crikey, this is a bit difficult. Let me bring the slides up on my other screen. Sorry, please bear with me. Talk amongst yourselves, or ask questions amongst yourselves. So we had to rebuild an awful lot of platforms. Thick end of nearly 100 platforms needed rebuilding. Some of it was quite intensive. We worked at 56 stations. We've only got just about 70 stations, so virtually every station was impacted to introduce the standard offsite, lowered saloon height, intelligent sliding step, same interface at every door for every passenger. Hang on. I'm afraid I can't see if my slides have advanced. Could somebody... Oh, crikey, this is awkward.
Hi, David. It's Toby. We can
Hi, Toby. I'm sorry, I'm struggling here. I've lost sight of my slides.
Yep. Okay. We can currently see your platform train interface works slide 19.
Okay. I've tried to move it on. Toby, do you think you might be able to move the slides on for me so that the rest of the audience can see what I'm looking? I can see the slides on my other screen. So the next one is a lot of photos.
Yeah, with lots of construction machinery.
Absolutely. So we basically spent the thick end of a year doing this to our network. So it wasn't just a case of nudging a couple of coping stones around and repainting the white lines. This was a heavy duty major program of works, disruptive. I have to say, I was really pleased with the way that we managed it. We communicated very clearly. It's something we pride ourselves on. We are relatively good at communicating with our passengers. We pride ourselves on it when we do major infrastructure works. So every single section of this was handed back. Typically, we had 9-day blockades, which we moved around the railway, provided a good replacement bus service, and we were able to provide. Nobody was unable to get home. They were a bit inconvenienced, but the level of complaint we got, considering how intense the works were, I was very pleased. It was very small. Could you move on to the next slide, please, Toby, which is PTI infrastructure ready?
Yeah.
Okay, thank you. This, again, I'm not going to try and read this to you. All this is the heights and offsets of all the platforms after we surveyed them. We've got, well, the numbers is showing that even though it's not the most precise way of moving coping stones around and rebuilding platforms, we were able to get a really good tolerance on the engineering works that we did. And I have to say, having now tested those platforms, it's great. We're going to deliver a great. The risk of sounding like Chris Whitty. Next slide, please. Okay, so we think we're going to benefit from a hugely improved platform interface. New units are introduced. It's a systems engineering effort. It needed that engineering attitude that we had, looking at all elements together, not just relying on the ROM and solving the ROM. It can't do it on its own. We also got the political determination that they knew that the politicians liked the idea, and we got them to accept that, look, if you're going to do this, if we're making an omelette, we've got to break some eggs and spend some money. They stuck to their guns, which was really pleasing. So the benefits: safety, accessibility, and operational benefits in terms of dwell time. Every passenger, every doorway, every platform, and every crew member. And I would say this is an approach that is more widely available. How would people want to consider it on other railways? Not just because we basically got one type of rollers on our rail. The reason that you could apply it widely is because we adopted the Network Rail standard. So every train on the network should fail to hit a platform that is using the Network Rail standard dimensions. So even if you've got a mixed traffic railway, this approach would work if you introduced rolling stock of a similar type to ours. Okay, let's move on to the next slide, please, Toby. Okay, train lengthening. This is another component of the infrastructure. It's basically modifying the infrastructure. And part of the way in which we're able to carry more passengers is our trains are a little bit longer. Rather than being just under 61 metres, our units are now 65 metres long. So by the time we double them up, and we'll be running them as 8 cars, they're getting on for 10 metres longer than the existing ones. So we've got a variety of platform extensions that we're still doing the design work on. We've got signal moves. We've got there's some very, very intricate track work to be replaced at Liverpool Central, which is going to be this Christmas's blockade project. Wish us luck with that one. It's going to be super tight to get that in. And Network Rail, they're actually now well beyond Grid 3. This slide's a little bit out of date. We're most of the way through Grid 4. We've got all our contractors in place, and these works will be delivered over the course of the next couple of years in advance of us being able to run 8-car trains across our network. Okay, next slide, which is about traction power. Okay, the new trains are considerably more powerful than the existing ones. This is part of the metro train ethos that I've been seeking to introduce. Metro trains, as I'm sure many of you know, they are really good at accelerating and braking. And our train has got a performance spec which is written very much, it's derived directly from actually a Far Eastern metro train. So we're looking to deliver 10% journey time reduction across every route. We're looking as though we're on track to be able to do that. But one of the consequences is we do need much more powerful rolling stock. Our networks, the station spacing is only slightly over a mile. I think we, possibly together with the London Overground, are the most tightly packed station spacing. It really does feel much more like something like the Metropolitan line to me. So we've got 3 times more installed power, 2.1 megawatts peak. We've had to boost the infrastructure, so there are now 8 brand new substations commissioned. We've got 2 more to go. We have voltage drop on our network. It's one of the Achilles heels of the network, and we're addressing that. And we've also we've challenged what the current draw on the network is. So 4 kiloamps, I know, is what is the norm for the DC railway here in the UK. We've pushed it. The standards allow you to go up to over 6,000, but we pushed up to 5,400 amps. And obviously what we're looking to do is to squeeze the maximum performance we can out of our fleet and control the jerk rate, which is great. And it does. The trains, not only, they do accelerate considerably more powerfully and brake faster, but the jerk rate is well controlled on the train. So we're going to get a comfortable ride for our journey, for our passengers. Got 3 new bulk supply points with Scottish Power. Those are in the process of being installed. The railway, it was one of the weaknesses of the railway. It was only supplied from 3 locations across the whole of the network, which is part of why we were getting pretty high voltage drop. The 8 new substations, as I say, those are in. A couple more to go. Lots of cabling, and I have to say, hats off to Network Rail. They've continued the delivery of this project throughout the COVID pandemic. We were fully mobilised on site when March last year turned up, and we've hit every single major milestone since then. I'm really, really pleased with the attitude that's been shown. So thank you to colleagues from Network Rail. I guess onto my team a little bit because we were pushing for that. But anyway, it's been delivered, and we're very close to the end of delivering these works now. Okay, next slide, please. So wireless connectivity. Right, interesting. I was really taken. IMechE lunch. I'm sure 1 or 2 of you go to that. Does anyone remember when the head of British Airways engineering turned up at this event to give the speech that everybody the times? And rather than sitting there wondering about who was going to win 40 quid or whatever it was, actually, that's the chairman's speech that people time, isn't it? Anyway, never mind. So rather than sort of chuntering away and catching up with me, suddenly myself and one of the other engineers from the team, we started listening to this fella. We always listen respectfully, of course. But suddenly he had us. He talked about the journey that British Airways went on, going from the Boeing, it was the 747 from the 1970s, moving on to the 777 in the 90s, and then onto the Dreamliner in the current decade, actually no, the previous decade, and talking about the evolution of wireless connectivity between the vehicle and the infrastructure and the step changes that they've been through, really, really got us thinking, because I've been trying to write a business case for how on earth do you write a business case for giving good Wi-Fi coverage to passengers, particularly on a relatively short journey railway like ours. And I failed completely to write a business case that did anything other than just spend lots of public money on giving something that might not be good to passengers. We turned our logic on our head. We said, we've got an awful lot of new technology on board these trains. Wouldn't it be useful to get hold of that technology from the control centre? And we've had an integrated control centre on our railway since the 1990s. So we thought about things like accessing CCTV images real time from the control centre, and we've subsequently expanded that to include the BTP. Managing incidents, getting voice communication onto the train. You've got your GSMR radio, yes, but you're still relying largely on the onboard staff to communicate. If we can empower the control room to be able to see and interact with the saloon, we think we could have something really, really powerful. As well as knowing things like how many passengers are on board the train. Use the onboard passenger counting technology that we've got on there. Remote diagnostics is fairly well proven within the industry, but we can benefit from that. Infrastructure monitoring as well, again, enabling Network Rail to work out where the weaknesses in their infrastructure are. So our view was, if we can do all of that, when we're not using it for operational purposes, we can let the passengers use it, and all the kids can ignore their parents and sit there on their phone, well, we all do it actually. So the conclusion is, we wrote a spec that said we want to get 100 megabits per second to all trains everywhere across the network, including through our tunnel network. Our tunnel network is about 7 miles long, slightly under. How are we delivering it? Well, again, competitive procurement. Panasonic, who now own AD Comms, which is again a well-known name from the rail industry, some of you might be familiar with, introducing a trackside Wi-Fi solution. So we're building fibre optic network, and an awful lot of masts are going out there at the moment. We've completed all our surveys. The design is practically complete. The solution works in the lab. First train installation is complete. We've actually now about halfway through testing the first train, and we've been able to get the CCTV visible from Scunthorpe on board the train. That's where Panasonic's operation is based, and we're halfway through getting the voice communication to work. We've got it working in one direction so far, but I think we found out what the problem is there. And the main construction well underway. We want to roll this system out over the course of, as we roll the fleet out, this system will go with it. What most passengers will see is they've got a free, decent Wi-Fi provision, but in reality, the business case is about an awful lot more than that. It's about connecting the intelligent kit on the train to people who can make use of it who aren't on board the train. Okay, next slide, please. Collaborative working. This is, many of you who've delivered projects and programs of work like this will know that this is the truth. This is very much true. The projects are complex, they're multidisciplinary, and you've got organisations who you have to get an alignment between them in order to deliver successful results. For us, as well as Panasonic, who are slightly to one side, but we have the 4 key organisations for us are Network Rail, Merseyrail, the operator, Stadler, the rolling stock provider and maintainer, and Mersey Travel, the public authority. And we're not visible out on the actual active railway. We don't have a role in the safety case for the railway, but we do have a role in orchestrating the activities of the various other parties. And hopefully this will be a hallmark of this programme. I'd say it has been so far, but we've still got quite a lot of water to go under the bridge to make sure that this is what we're remembered for. What you need, clarity of vision, a governance framework. I actually chaired the board. We have a strategic board where we have relevant key board members from all of the organisations in place. I actually chaired that this morning. Successful, issues shared, actions agreed, resolutions determined. Willingness to share information is a big thing, which is not always easy, not always germane to everybody, but it's part of it. Recognising each other's perspectives and on occasions compromising, which I'll characterise as meaning agree with what I just told you and you're fine. I don't actually mean that, by the way. Okay, next slide, please. Managing the transition. So this is the phase that we're in. We're close to the end of testing. We've handed back the first 2 units of our old rolling stock. When we say hand back, that means tow them off to the scrapyard. So two of the old trains made their way to Wales and will never be coming back. But there's a lot more. We've got another 57 units to hand back. New fleet delivery and testing. Well, we've got as many trains in the UK as we can cope with on our network. The network is not huge. We don't have unlimited stabling, and we're very close to the end of testing. We just need to really get a few more of our testing engineers into the country to finish it off. Getting the infrastructure interventions done in sufficient time that we can conclude the testing successfully. There's a lot of retraining of both the operational staff and the engineering workforce, and that's the engineering work in particular is now well advanced. Just managing the capacity of the network. This is a live operational railway. That generally almost always takes priority in the running of the day-to-day railway. There's lots of interfaces between the various disciplines and the various organisations, and it's about key core project management and getting milestones established, understood between the parties, agreed, and communicating with each other on a virtually permanent basis. So this is the phase that we're now getting into. And other than, if it wasn't for COVID, I'd say we'd be doing reasonably well. The plans all look great on paper, but it is a bit difficult without the engineers. Okay, if we can move on to the next slide, please. Okay, timelines. So, started with what was not quite a blank sheet of paper, but there was a bit of work that basically focused on we've got old trains, therefore we need new trains. I came in 2012, and we spent quite a bit of time writing the business case, and there's as much time just doing the work of doing the financials and working out what your strategy for delivery should be. A large part of that time was spent actually doing stakeholder management and getting support from various organisations, most notably across the city region, but into our colleagues at Network Rail. Obviously have a national perspective, making sure the DfT were tuned into what we were doing. We went through the creation of our combined authority, which you down in London, you've had your equivalent for a lot longer. It's headed by Sadiq Khan at the moment. We have Steve Rotherham as our equivalent, and that organisation didn't exist when we started trying to write the business case, so that had a big interaction with it. We finally got to the starting gun was getting the rolling stock procurement underway. Started in late 2015, and we got to contract award with Stadler about 15 months later, in February of 2017. So for a public procurement, that's reasonably quick. Maintenance transfer took place just over 6 months later, and we tupied 150 members of who'd originally been Merseyrail employees became Stadler employees and got their lovely blue overalls. Rolling stock design, we cracked on, got that completed in September of 2018, and then deliveries off the production line started in autumn of 2019. Infrastructure work commenced in 2018. It's going to stretch out into 2021, and we're looking forward next year. We were originally planning to get units into service last year, but I'm afraid the pandemic got us, as it probably has done many other projects. So we weren't able to do that, but we're looking forward to getting our units into service over the course of this year. The key lesson I would say in this is try and avoid a pandemic, because it really isn't a very helpful thing at all when you're trying to deliver a major program. Okay, if we could have the next slide, which I think is the final one. Okay, working in partnership, something that's quite dear to me. Some really interesting people on this. This actually was outside Lime Street Station. We had nearly 25,000 people came and visited our wooden mock-up and told us what they thought of it, which was not universally, but over 90% very positive, which was great. And we just had an august group of individuals here, so I'll run through them with you. On the left, we have Adiola Dada, who's one of Network Rail's sponsors, who delivered the platform train interface works for us. Hein van der Schoot is next to Adiola. He's just moved on, but he was Stadler's managing director for the UK at the time. Lucy Middleton was one of Network Rail's project managers. I'll come back to the chap in the middle with the grey shirt in a minute. Lady in the wheelchair is Pam Thomas, who's one of our councillors, who's a big accessibility campaigner. I've known her for many years on tramway networks. Actually, Manchester Metrolink is where I joined Merseytravel from. She's hot on the subject of accessibility, so it was great having a political ally who was prepared to support us and also push us. Standing next to me is our Metro Mayor, that's Steve Rotherham, who you sometimes see in the national press and you read about him in the newspapers. And over on the left is Andy Heath, who's the managing director of Merseyrail. And it really does require working together like this to make programs like this happen. The chap in the middle, Dean, I was really chuffed. I like giving people an opportunity to develop their career. Studying mechanical engineering, I think he was doing the BTEC level 3. Wandered over on the mock-up. I was doing my shift on the mock-up, and this chap turns up, starts talking to me, knowledgeable, very knowledgeable, knows an awful lot about railways, knows an awful lot about our railway, probably more than I do, to be honest with you, because he's lived here all his life and has studied it and intimately grown to know it. Really, really interested. So he came and did a he did from memory a 3-week work placement. He was in the middle of doing it with us. Did a bit of time with me and then a bit of time with Stadler over in the workshop. Really got the fire in his belly, and I'm delighted to say now he's joined our industry and is now working for Merseyrail. And he got his BTEC as well. So I was really pleased for him. So it's great that projects like this can also help provide a path into the industry for the generation that come behind us. Okay, and the next slide there is one more slide, but all it says on it is questions. So at that point, I'll have a sip of water and I'll hand back to Toby to run through the questions. I've seen there's been quite a lot coming through, but I haven't had a chance to read any of them yet. Okay, so thank you very much for your attention.
Thank you, David. That's a very, very interesting and fascinating talk. Thank you for that. My name is Kevin Moore. I'm just going to host what is a very good big array of questions this evening. So we'll endeavour to get through as many as we can. For those attending tonight, expecting the Deep Tube talk, which has been deferred, there are considerable parallels, I think you'll agree, this evening with what would have been the underground stop presentation, particularly around the theme of high capacity, air-cooled, walk-through, accessible trains. And it's reassuring to see that you've approached this in a similar way about optimizing design, specification, and systems thinking. So without further ado, there's a whole range of questions to touch on, so I'll just try and select a few. So David, can you tell us more about how you consider dwell time performance and how you think this will hold up given the door configuration on the new units, and have you explored this by means of any modelling or physical testing?
Yeah, great question. And yes, we have. Dwell time. We're looking for a basic dwell time of 30 seconds. Most of our stations, that's what we timetable at the moment. It works reasonably effectively. It is a bit variable. We think we'll be able to control it better on this. I think whoever asked the question, I think it's Louise, has probably spotted that we have a 4-car unit and the door configuration. It's symmetrical across the centre line of the train, but the 2 centre cars each have 2 double doors on, and the end cars, which are slightly longer, only have 1 double door on them. So yeah, we did think about that long and hard. We did do a computerised simulation of that. Oh, crikey, it slipped out of my mind what the piece of software we used was. It'll come to me, and I will remember. Apologies. And then we've also done physical testing as well. So we've had a large number of people doing evacuation tests, but also just testing dwell time at a mocked-up platform in Switzerland. We're confident, but the real proof of the pudding will be out in the real world. We'll be measuring it very, very carefully indeed. Broadly, we felt that the benefit of the easier platform train interface, we felt that at some platforms we have step up, step down. There can be a step of 400, 450 millimeters, or at least there used to be, which was quite difficult. The other variable that we're taking out is we don't believe that we're going to need platform ramps to be deployed anywhere anymore. A wheelchair user should be able to get on and off these trains totally unassisted. They certainly meet the standards that are contained in the PRM TSI for unassisted access, and it's the same standard that the tram industry works to. And there are examples of that in other parts of the railway as well, albeit we've just done it at every doorway on the train.
Thank you, David.
Okay.
Well, now on reliability, the Stadler trains for Greater Anglia, introduced last year, have been struggling somewhat in terms of reliability. What have you done to ensure the performance of your Stadler trains does not similarly struggle?
Yeah, we've watched that as well. Very, very aware of it. Well, first thing is we haven't bought the same train. It is the only component that I'm aware of that is common. You're going to like this. It's the coat hook. So we have coat hooks throughout the saloon, and the reason we've got the same coat hook is the Anglia trains were built. They were around about a year ahead of us. And I took a look at one of the Anglia units in the factory, and I said to the standard designers, we were just finishing off the design phase. I said, I prefer that coat hook. Could we have that one instead? Yes. So look, I also know that Stadler's performance for that region, it got off to a difficult start. I've had the insight from both Stadler and friends at Abellio as to what happened. I'm not going to. That could be a lecture all in itself. So I'll leave it for them to talk to the institution about that. But we've got a fairly good idea of what happened. The systems that were proving challenging, we don't have the same systems on board our train, or if we have the same system, it's not the same supplier. Now, we might well have our own problems with the suppliers that we have ourselves. We also put a lot of work into reliability modelling as part of the design process. So we are anticipating that we'll get a significantly better result. To be contractual about it, I've also got the value, the significantly better contractual value built into the contract with a rather large bag of money on it. So I hope that money isn't the only thing that motivates Stadler to get there, but I think they will. I think just making their own lives easier by having a reliable piece of kit will hopefully motivate it there. But so it's a great question, and at the moment we're sort of halfway down the V curve. We've got the other half to go up, so we will undoubtedly encounter problems. Every new fleet does. We've been encountering problems in testing. We've been solving problems in the testing phase as well. Another thing that we're doing, actually, we're using some of the time we have at the moment where we haven't got the engineers in the UK and we can't put the trains into service. We're doing shakedown runs at the moment. So they're not actual tests, but we're just running the trains around in a shadow service, just to iron out the glitches.
Thank you, David. Moving on to the batteries or battery trials. Two parts to the question. If the battery trials are successful, would you then go on to modify or fit the whole fleet? The second part of the question would be, have you therefore designed the suspension of these units to cater for the battery loads? Okay,
well, the first part of the question comes from somebody I know very well because he was my rolling stock project manager for up until the end of the design phase. So thank you, I appreciate the question. The answer is we've done a bit of business case modelling work, and you have a choice. If you were going to run on a particular route on battery as an IPMU, you would obviously only need to fit the number of diagrams that you need on that route, plus a complement of additional units in order to be able to basically create a subfleet. The batteries have two benefits. So it's not just about running off the infrastructure. It's also about being able to always benefit from regen braking. Now, we've introduced regen as part of the new fleet. It's never been on our network before. We just burnt all the energy off into the atmosphere. And it works, but it's not that effective on most of the network. We don't have the intensity of service pattern to give ourselves receptive trains that frequently. So having a battery on board also means that you can effectively do the equivalent of regen braking pretty much every time you brake. The business case points towards creating a subfleet. The environmental case could tip it the other way. So the answer to the question is not yet decided. There's an argument to be made for both, and we think we've got a good understanding of both. We'll be using our trials that take place this summer to hopefully inform that and make a decision. But if I was a betting man, I'd say we'd start off by creating a subfleet. But I'm hopeful that we might see more and more routes become battery powered, and that then would increase the logic for the whole fleet being fitted. So that was the first half of the question. Can you just remind me, sorry, what was the second part? There were two battery questions, weren't there?
That suspension loading and suspension design?
Yeah, very much so. The axle load is the determining factor. So we're an AW3 train. We are limited to 16.5 tons per axle. And that's just been an absolute limit. That's what our infrastructure is designed to work with. So yes, you've got to be careful about where you put the batteries. With the train without the batteries, the two centre axles are the most heavily loaded. So the battery packs have to go on the end cars, which have got the trailer bogies and less equipment in the underframes. So yes, it's been thought through very carefully, but it's all about managing axle load.
Thank you for that. What about kind of migration between new and old stock here? So have you lost some safety, accessibility, etc., using obviously with the new platforms or modified platforms and running the old stock during migration? So how much is this? How much is a concern to Merseyrail?
Okay. So how many platforms have we actually made worse by moving them? Yes, there are a few. It's not very many. It's around about a dozen from memory. And we talked it through with the ORR before we went ahead and did the infrastructure works. So we had thought about it. And they said it's for a temporary period, and what you end up with at the end is significantly better. Therefore, we're quite relaxed that you do that. And it's still a safe platform chain interface. You've got the Fibre 7508s with their floor height of 1100 and whatever it is, and a platform that's at 950 millimeters. So it's still a relatively comfortable step, even if it was a slightly lesser step in the past. So we talked it through with the regulatory authorities before we committed and did the work.
Great, thank you. Returning to the train and the comms, really, what considerations have been given to cyber security, given the wireless connectivity of your new trains?
Okay, that's an extremely good question. Quite a lot, and we still are doing so. Back when I started this, back in 2012, I'm not sure I really knew what cyber security was, if I'm being honest with you. I had a vague notion. What the first thing is, yes, we've got the wireless connectivity to the fleet, but most of the train's control systems are completely separate. So the train can run. We've designed it so that system is not remotely safety critical. That if it doesn't work, it's not there for whatever reason. It can't get into the other systems. They're not physically connected to each other on board the train. So there's no way you can get into things like the doors, the brakes, the traction control. There's no interface between them. I'm afraid I'm probably not best placed in my team to give you a detailed answer in relation to the rest of it. I've sat in plenty of meetings being mildly baffled by people who understand cyber security better than me. So apologies, that's not the best answer about what we've actually done. But I think the question came from somebody from Angel Trains. I'll be very happy. We have a very strong relationship with Angel, and I'd be very happy to arrange somebody who knows a bit more about it and could give you a better answer if you wanted to get hold of me outside the meeting.
That's great, thank you, David. Maintaining the kind of theme of onboard systems, really, are you considering remote monitoring for predictive capability for train maintenance using the onboard facilities now?
Yes, we are, very much so. That's something Stadler do anyway. It sort of goes with the DNA of Stadler Rolling Stock. They have a standard maintenance management system, which goes by the exciting acronym of SRMS, Stadler Rail Maintenance System, which they use across the world. So we've got a version of that we've configured to meet our purposes. We're able to use our wireless connectivity to give better connectivity to that system, so it can work more in real time. The other thing that we're doing is we're considering whether there might be some initiatives beyond the introduction of the train, whether looking at predictive maintenance might be a feature of what we do. It's not something we've done on our railway before, but we're aware of some examples of good practice in other parts of the industry. So together with Stadler, we're at the early stages of exploring whether we might want to invest a little bit more in putting some additional sensor technology on board the train to see what that could tell us. So we're at the beginning of a journey there, I would say, but we're very open-minded, and I certainly get the theory. I've just actually never done it myself, to be honest with you. I've probably lived on more old-fashioned systems through my career.
That's great, thank you for that. There's been a couple of comments on really the body shell and body side, referring to or commenting on the Toblerones in terms of the design.
Yes, yes, they're triangular in those splits.
Yes. It tells more about those features. Are they longitudinal features on the sole bar onto cant rail? I think
They are. They're just above the sole bar. They run down the body side between where the doors open, and then we've also got them on the door leads themselves. That is a platform gap filler. So it makes the gap, which otherwise, where you've got the tumble home that tucks in on the side of pretty much every piece of UK passenger rolling stock. If you started to fall down there, there's nothing to stop you. If you start going, you're going to go until either you're all the way down there or your body stops you and you've got your leg hanging down there or some other awful configuration. This is to reduce the size of the gap, but also to make the gap more vertical rather than it being a diagonal gap. So it means that in order to get down the gap between the train and platform, we can't totally eliminate a platform train gap, obviously. But you'd almost have to be on the platform, rolling towards the platform edge to be able to get underneath that and down the gap. So you'd also have to be an awful lot slimmer than me to be able to do it. So yeah, and they have been christened the Toblerones because they're triangular and they're Swiss. The ORR commented very, very favourably on those. It seemed to be an appropriate part of the response that matched very well with the platform works that we do. We think platform train interface safety is big for us, as I know it is for the whole of the industry. But that's one of the ingredients of our approach to it.
Again, thank you for that. That's very helpful. Coming back to reliability, but this time about the platform sensing step, the intelligent step. Obviously, that's critical to dwell time and obviously service delays, etc. Can you tell us a bit more about how you evaluated that before they introduced the service? I
can. I'm sceptical as well. I thought this is just a source of unreliability that we're going to be designing into the train. What do we make of this? Nonetheless, open mind. So while we were doing the bidding phase with Stanley, we went over to visit them, and we kicked the tyres on what they do on other railways. And it's pretty much a feature of every Stadler train. It's certainly just about every one I saw coming out of the factory. They've got a sliding step, and the latest generation ones have got this ultrasonic sensing technology. We pushed hard. We wanted evidence of how well proven that was, and what we got back, albeit it was in German, but then again, in Switzerland, we got a lot of evidence that was sourced from SBB, and we saw an awful lot of trains out in Switzerland that have the same technology. And there seemed to be, from what we could gather from the discussions that we had with people out there, a good bill of health. Similarly, we know that it's employed on Deutsche Bahn successfully as well. We haven't seen any problems in testing. It doesn't seem to be an unreliable piece of kit. It's relatively straightforward. We'll have to see. I mean, if it does start to prove unreliable, it also forms part of the contractual reliability target. So having doors that need to be isolated out of use is not what we want at all. But that's how we would address it. If it happened, we could run with one door isolated out of use, but we don't want to. So hopefully we've done our homework. The proof of the pudding will be in the eating over the next couple of years as we go through our reliability growth phase, which every fleet has to do.
Thank you for that. There was a secondary question about what happens if doors open but the step didn't. I think you kind of covered that, which is you probably
we'd get the onboard staff to isolate the door out of use.
That's great. Thank you for that. Sort of related to that, really, door control operating gear frequently is a source of reliability problems. Do you think that adding sliding footsteps is going to exacerbate? I think you just covered that one really, which is it obviously compounds the reliability problem you have, I guess.
Yeah. Yes. Potentially. Again, I was pretty sceptical when I went out to Switzerland. Challenged it, pushed it. Yeah. I got comfortable that this stuff, if it works in Switzerland, why the hell isn't it going to work in Liverpool?
Great stuff. How many of the 52 trains have now been completed, and are they now having to be stored over on the continent if there's no more room over here?
Yes. Let me just do my maths. bear with me. We've got 12 at Kirkdale. Hang on, no, sorry, that's wrong. we just moved some. We have 8 at Kirkdale. We can't take 12. We've got 4 at Crewe. Some of that is because there's a modification programme that we needed a bit of additional workshop capacity, so we've got workshop space down at Crewe. We've got 2 in a siding at Warrington, and we have 4 parked up in Poland at the moment. We've also slowed the production down with the challenges we've had with testing and getting them into service. Stadler were able to flex their production demand down, so that we're just not stockpiling rolling stock. But there is a bit of a buffer that we've already built up. We haven't yet accepted any of the new units. That's coming up, but the testing's got to be completed before I can accept them. That will hopefully take the pressure.
Great, thank you for that. Couple more. Did you use a full systems mock-up using actual equipment off-site or in a warehouse to help deliver reliability predictions ahead of actual introduction?
No, we didn't. I'm familiar with the approach, but we didn't do that. What we did is a lot of going into the service records of the various systems on board the train. The basic mechanical design is bespoke, but hopefully the body shells aren't going to prove to be a source of unreliability. A lot of the elements of the train are based on already existing equipment, and we've been able to access their reliability data from other projects. But no, we didn't go down the full mock-up route for that. What we have spent a bit of time is proving accessibility for ease of maintenance. Again, it was one of the benefits of having the maintainer and the rolling stock manufacturer at the same company. I won't say it was perfect, but it was quite well delivered in that the train was designed with maintainability in mind. I think every train could probably be designed better with maintainability in mind, but we had a good go on this one.
Thanks for that. The line-side signalling system, obviously that presumably is a network rail today. Is there any intention to move towards a cab signalling system in the future?
In the future, yes. We're future-proofed for ERTMS. Our signalling system is a miscellany of all sorts of different things that have grown up over the year. We still have semaphore signalling on board the network. So it really is, it's old stuff. But yes, we envisage as network rail hopefully will be rolling that out over the whole country. And these trains are on our network. We're not intending that they go anywhere else. They're not owned by someone else who could lease them elsewhere. They're ours. We're intended to keep them on our network, and we're sure that in the next 35 or so years, that technology will make its way to our network, and we've future-proofed the train ready to take it.
Okay, a couple of final ones. Do you still have plans for the potential dual voltage 750 volt 25 kV operation with these trains in the future?
The answer is if there was a 25 kV overhead line that was usable by us, we'd be perfectly happy to do so. We've got the 25 kV system designed. We've got it costed, so it's a priced option that I can just draw down from Stadler as and when we need it. I'm afraid at the moment though there just isn't. There's one very small stretch of 25 kV overhead at the extremity of one of our routes, but it's only about 200 meters long, and then it goes off in a different direction. So if over the life of our trains 25 kV starts to proliferate up in the northwest of England, we'd love to take advantage of it. I'm a fan of 25 kV. The thing that we can't do is we can't have a train that has the batteries and the 25 kV equipment because they take the same physical space up. So it could be that for the short to medium term, if we're expanding the network, it could be battery based, possibly extending the third rail if that's going to be permitted. 25 kV would be great, but we'll keep our options open. But yeah, it's 25 kV is definitely designed in, and it will fit elegantly onto this train. I guess it also means from Stadler's perspective, if they wanted to sell this onto a railway, something like this onto a railway that had 25 kV, they'd be able to do so.
great. Thank you for that. And still on the theme of batteries, then, could you reach as far as Wrexham from Bidston using the additional battery system? And are there any plans to go that far afield?
Yeah, but I don't think we'll ever get back. Yes, we've simulated the Bidston-Wrexham route. So for those who are not familiar with these strange-sounding locations, Bidston is a town at the north end of the Wirral, which is the peninsula on the left-hand side of the River Mersey, between the rivers Mersey and Dee. Up at the top end of the peninsula is Bidston, which is an interchange at the moment between the Transport for Wales service, which runs up what's known as the Bidston to Wrexham line, because it goes between those two locations. It's quite a challenging line in terms of its topography and its line speed. It's slow, it's twisty, it's got steep gradients on it. It's not very well used. It's one of the locations where Merseyrail are going to be introducing their stock, which hopefully will be a significant improvement over the DMUs that they've been operating for many years. It's one of the unloved corners of the UK's mainline network. We would love to be able to provide much better connectivity between North Wales and the Liverpool City region, and that is a key route for us. Both we and our colleagues on the other side of the border would like trains to be able to serve our city centre from Wrexham directly. We think that would be great, and I think there is a commonly held view that a version of our train would be the right piece of rolling stock to do it, because it's designed to go through our tunnel network. The way to do it is either electrify the route in some way, which costs a lot of money, or I'm hoping in the summer that when we do our battery trials, we can prove that you can do a partial electrification of a route. Now, that doesn't mean to say I'm going to stick partial electrification on there, but we can use the electrification we have on the Merseyrail network, that you could run for a stretch. Maybe you have an electrified section in the middle that could be, well, it could be whatever it is. It could be third rail, possibly. It could even be 750 volt overhead, tram type electrification, but I don't think tram system would deliver the current that we're looking for. And then probably a charging station down at the southern end, down at Wrexham, to give us enough charge to get back again. So that is very much in our thinking. We'd love to be able to do it, and hopefully we'll get some good news later on this year that makes that vision a little bit closer. And I'd love to improve that railway, because it's not great at the moment.
That's great. Thanks, David. I think we're approaching time to wind up. I need to allow time for Toby to sum up, but one final question, really. Energy savings, going back to that theme, in addition to more efficient traction motors and higher current limits, how else is it to be achieved?
Okay, there's regen. It just is more efficient. Traction has moved on several generations. We've done our first energy consumption measurements. The formal test is the Chester route, which goes from Chester up the Wirral, round the loop under the city centre, and then back to Chester. That's the one that Stadler got to pass. First time they tried it, I'm still waiting for the test report, but it looked pretty good, and we're looking at a 25% energy reduction. The new train also, I have to say, even though it's bigger and it carries more passengers, it's actually lighter. It weighs just over 100 tons, whereas the old trains weigh I think, around about 105. That's just down to smart engineering, and welded aluminium body shells can be really, really weight efficient. It's got fewer bogies. That's another thing. There's one fewer bogie on it. That's broadly it. I mean, the old traction system really is not very efficient at all. It burns an awful lot of energy off, and it does it every couple of minutes. I'd love to put the batteries on board the trains and just recycle the energy, even though the business case doesn't quite wash its face at the moment. I think in time to come, it might. I think battery costs will drop. Size and weight of batteries will also come down, and we own these trains for 35 years. So even if that business case doesn't quite work at the moment, I'm hopeful that in time it really will, and we'll be able to make our trains even more energy efficient.
That's great. Well, thanks, David. That's really, really helpful. I'll pass over the mic to Toby, who's happy to sum up.
Thank you. On behalf of the Railway Division and tonight's audience, I'd like to sincerely thank David for agreeing to give tonight's talk at such short notice. your presentation really has over-delivered on expectations, and I think you set the bar high for your Transport for London colleagues who will be presenting later in the year. Your presentation clearly demonstrated the benefits of consultation with your customers and stakeholders. This is evident in the novel solutions to improve the platform train interface for passengers with all mobilities. You clearly articulated how the introduction of new rolling stock needs a whole raft of infrastructure improvements to deliver on a successful outcome. The trains are the centrepiece and they're clearly impressive, but I'm sure that the invisible to the customer upgrades will contribute equally to their enjoyable experience. This is clearly an impressively specified, managed and executed project. I, for one, I think will be planning a trip to experience the results when I can and restrictions allow. So, David, thank you very much for your presentation tonight.
Thank you very much. I look forward to hopefully welcoming as many people are interested. Come and find us in Liverpool. We don't bite much.
Yeah, I would encourage everyone to make the journey and experience the results of your labours for themselves. So all that leaves me to do is just to close tonight's proceedings. A reminder that the webinar has been recorded and will be made available after the event for replay. Thank you very much to Emma from the institution for her support in making this evening's webinar happen. Thank you all for attending, listening and submitting your questions. I hope you found the event very informative and enjoyable, and I hope to see you at the Future of Rail presentation competition on the 15th of February. Good night and thank you.